Continuing the tradition of naming planets after gods, the eighth planet of the solar system was named Neptune in 1846. Scientists conducted orbit calculations for Uranus, which indicated the presence of an unknown planet affecting its gravity. Although Neptune was not visible to the naked eye, researchers were able to confirm its existence using telescopes. In fact, astronomers had already observed Neptune through telescopes in 1612, but had not identified it as a planet at the time. Johann Galle and Heinrich Darst, German astronomers who accidentally discovered the planet, were guided by the calculations of French scientist Urbain Le Verrier. After the discovery of Uranus, astronomers noticed that the seventh planet from the Sun deviated from its predicted position during its motion. This led to the theory of an eighth planet whose gravity affects Uranus' orbit. Several scientists began calculating the location of this unknown celestial body, sparking a sort of astronomical race. Urbain Le Verrier emerged as the winner. After the discovery of the eighth planet, various suggestions were proposed for its name. Johann Galle proposed calling it Janus, while Urbain Le Verrier initially suggested naming it Neptune but later considered naming it after himself. Ultimately, the eighth planet of our solar system was named Neptune, continuing the tradition of honoring gods through the naming of planets. Furthermore, the name fit perfectly as it blended well with the planet's blue color, much like Uranus. Neptune has a solid core the size of Earth and is composed mainly of water, ammonia, and methane. Its atmosphere is made up of hydrogen, helium, and methane, and it is precisely the methane that gives Neptune its bluish, or rather, bluish-green color. What few people know is that Neptune has 6 rings in its orbit, although they are imperceptible to the human eye. Neptune is about 4 times larger than Earth and takes 164 years to complete one orbit around the Sun. Despite identifying Neptune in 1846, humans only got to know the planet better over 100 years later. In 1989, 12 years after the Voyager 2 spacecraft left Earth, it provided us with the primary information we have today about Neptune. After passing within about 5 kilometers of the planet's north pole and spending 5 hours orbiting it, Voyager 2 confirmed the existence of its largest moon, Triton. Neptune is an icy planet located at a great distance from Earth, yet it exhibits some intriguing similarities. For instance, it experiences seasons that can last for decades, unlike Earth's seasons, which only endure for months. Neptune is known for having the strongest winds in our solar system, with gusts reaching nearly 2,000 kilometers per hour, roughly twice the speed of sound on Earth. The exact source of Neptune's internal heat is still a subject of debate among astronomers. As you delve deeper into Neptune, the temperature and pressure rise rapidly. Computer simulations revealed that at a depth of approximately 7,000 kilometers, the pressure becomes so immense that methane decomposes into its constituent elements, carbon and hydrogen. The lighter hydrogen rises to Neptune's atmosphere, while the carbon, subjected to the surrounding environment, transforms into diamond crystals that slowly descend toward the planet's core. As for Neptune's moons, shortly after the blue planet's discovery, experts found Triton, Neptune's largest moon. In total, the planet has 14 confirmed satellites in its orbit. Triton possesses peculiarities compared to moons of other planets, as it orbits in the opposite direction of Neptune's rotation, a phenomenon known as retrograde orbit. According to NASA, many scientists believe that Triton actually originated from the Kuiper Belt and was eventually captured by the gravitational pull of the blue planet several thousand years ago. With a diameter of 2,700 kilometers, Neptune's surface exhibits volcanic characteristics, with large round pits formed over the years by frozen lava. Considering all these features, one might assume that Neptune is an uninhabitable planet, and indeed, that assumption is correct. At least in theory, some scientists have noticed common occurrences on the planet and are trying to find conditions for life there. With the discovery of exoplanets, scientists have been exploring the possibility of life beyond Earth, and one of these planets is Neptune with its vast oceans and extreme temperatures. Neptune may be home to some form of alien life, and scientists are now looking for ways to explore the depths of Neptune to discover if there is any evidence of life forms on this distant planet. Using telescopes, probes, and other advanced technologies, researchers hope to make discoveries that can prove once and for all if there are aliens beyond our own planet. The moons of Neptune are of particular interest when it comes to potential habitability in our solar system. In addition to Earth, the two main moons have been extensively studied to determine if they could sustain life. Although there is still much to learn, recent research has revealed some interesting things about their potential for hosting life. It is believed that the two moons may have the right conditions for the existence of liquid water on their surfaces. Furthermore, the presence of organic molecules suggests that these bodies may be capable of sustaining life as we know it. However, more research is needed to truly understand if they could provide a habitable environment for living organisms. The characteristics of Neptune give some hope to scientists in the search for extraterrestrial civilizations in our solar system. This search has been ongoing for centuries, but it has been particularly intense since the discovery of Neptune. The planet is the farthest from the Sun and is one of the most mysterious places in our solar system. Could we find evidence of life or alien technology on Neptune or its surroundings? Well, this is the question that has fascinated both scientists and laypeople since the beginning of space exploration. From analyzing collected data to attempting to detect radio signals from Neptune, scientists have tried a variety of methods to answer this question. Unfortunately, we still lack this valuable answer, but what would it take to actually visit and explore Neptune? It would require a massive space exploration mission to send astronauts beyond the orbit of Uranus and eventually to Neptune. The mission would need to include a crewed spacecraft as well as robots and probes that could explore the planet's atmosphere, surface features, and moons. It would also need to be equipped with advanced technology capable of withstanding the extreme temperatures and radiation levels found in deep space. But unfortunately, we still have a long way to go for this to happen. So, in the meantime, we have to be content with the research conducted by space agencies.